Alright, now let's look at this question. This will test your concepts on Synapse Analytics SQL pull. Option E says reduce DWUs. Reducing DWUs lowers performance but doesn't eliminate compute charges during idle time. So the overall goal is to reduce operational cost without compromising the integrity of stored data. There remains idle the rest of the day it mentioned. So that's what we need to tackle. So option E is out. Option B says pause the pull. Pausing the pull stops billing for compute while preserving the data, which aligns with the goal of minimizing cost during idle period. Let's keep it. We'll move to C. C says create a user defined restore point. Creating a restore point helps with recovery but doesn't affect cost during idle hours. Wrong answer. We'll move to now D. D says delete the pull. Deleting the pull removes the data, which violates the requirement to keep it intact. Let's delete this option. If you look at the official documentation, it's mentioned if you don't need to use your dedicated SQL pool for a while, you can save compute cost by pausing compute. That's what is required. We'll lock option B, pause the pool, as the right answer. Okay, now let's look at this question. This is all about real time data. Option E says online transaction processing OLTP. OLTP is built for handling frequent transactions but doesn't support real time telemetry data ingestion. Incorrect. We'll move to now B. B says batch. Batch processes data in chunks, which doesn't align with real time telemetry data requirements. Wrong answer. We'll move to C. C says massively parallel processing MPP. MPP is optimized for large scale queries but doesn't support again a real time telemetry data ingestion. We'll delete this. We'll move to now option D. D says streaming. Streaming matches the requirement for a real time telemetry data capture and processing. That being said, option D, streaming, is the right answer. Alright, now let's look at this question. This is all about non relational data. Option E says no indexes. Indexes can exist in non relational systems. Their presence depends on implementation, not on the data model. Incorrect. Let's move to option B. B says self describing entities. Non relational data embraces self describing entities, allowing each record to define its own structure without relying on a fixed schema. Let's keep it. We'll move to now C. C says a well defined schema. A well defined schema is a trait of relational systems, not non relational one. We are looking for non relational data as per the question. C is wrong. We'll move to D. D says no unique key values. Unique keys can be used in non relational databases to ensure data integrity and retrieval efficiency. So here is just the opposite, no unique keys. So this is again will eliminate it. We'll lock option B, self-describing entities, as the right answer. Alrighty, we have a multiple choice question. Option A says database. We can configure throughput at the database level to share RUs across multiple containers. Let's keep it. We'll move to B. B says item. Throughput settings aren't applied at the level of individual items within a container. We'll delete this. We'll move to option C. C says container. We can assign throughput to a container by setting request units, that is RUs per second, that is RU per second, either manually or through auto scale mode. Let's keep it. We'll move to D. D says partition. Partitions are used for distributing data, not for setting throughput. Incorrect. We'll lock option E, database, and option C, container, as the right answer. Let's bring the heat to the snow. This is about analyzing continuous temperature readings. Option E says relational. Relational databases organize structured data well but aren't optimized for high frequency sensor readings with timestamps. Hence incorrect. We'll move to B. B says time series. Time series databases align with time-stamped sensor data, enabling efficient tracking and analysis of temperature changes over intervals. Let's keep it. We'll move to C. C says graph. Graph databases model connections between entities but aren't suited for storing sequential sensor readings with timestamps. Wrong answer. We'll move to D. D says columnar. Columnar databases accelerate analytical queries but aren't designed for ingesting continuous time-stamped sensor data efficiently. We'll delete this. We'll lock, and before locking, if you look at the official documentation, it's mentioned time series databases typically collect large amounts of data in real time from large number of sources. That's what is required. We'll lock option B, time series, as the right answer. Alrighty, we have a brainstorming question this time, and again the question is all about non-relational data store. Option A says key value. Key value store lacks native support for storing metadata alongside large binary content. It's incorrect. Option B says columnar. Columnar store is designed for structured tabular data and analytical queries, not for storing unstructured media files. Wrong answer. We'll move to C. C says object. So object store supports unstructured binary data with metadata and unique IDs, making it ideal or perfect for media and disk image storage. Looks good, we can keep it, because if you have used a blob, then objects you might be familiar, where we upload similar kind of content like videos, audio files, right? We can upload this kind of stuff, which is non-relational data store. Option D says document. Document store handles semi-structured data, that is text data, and is not suitable for storing large binary media files like videos and audios, right? D is wrong. We'll lock option C, object, as the right answer. Alrighty, now let's look at this question. This is all about JSON formatted. Option A is columnar. Columnar databases are designed for high performance analytics on structured tabular data, not for storing schema flexible JSON documents. Wrong answer. We'll move to B. B says key value. Key value stores are built for fast retrieval using simple keys, not for querying structured JSON with nested fields or schema logic. Wrong answer. We'll move to C. C says document. Document oriented databases store JSON efficiently and support flexible schemas aligned with application defined structures. Let's keep it. We'll move to D. D says graph. Graph based databases are built to model and traverse relationships between entities, not to store or query large volumes of standalone JSON documents. We'll delete it and lock option C, document, as the right answer. Alrighty, now let's look at this question. Option A says Azure Files. Azure Files supports SMB protocol, enabling Windows application to access shared folders through mapped drive. Let's keep it. We'll move to B. B says Azure Blob Storage. Azure Blob Storage is designed for object access via REST or software development kits and is not usable with mapped drives. Wrong answer. Let's move to option C. C says Azure Cosmos DB. Cosmos DB is built for distributed document store and is not compatible with file system access. Incorrect. We'll move to D. D says Azure Table Storage. Azure Table Storage is meant for NoSQL structured data and lacks file system integration. We'll delete this and we'll lock option A, Azure Files, as the right answer. Alrighty, now let's look at this. Again, we have a SMB based access patterns, so you might be already guessing the answer, which we have discussed in previous question. Option E says queue. Queue storage is used for passing messages between components, not for storing or accessing shared folder files. Wrong answer. We'll move to B. B says blob. Blob storage is optimized for object storage and lacks native SMB access for shared folders. Will reject it. We'll move to C. C says file. Azure File Storage supports the SMB protocol and is designed for lift and shift of Windows shared folders. Let's keep this. We'll move to D. D says table. Table storage is intended for NoSQL structured data, not file based storage. Incorrect. We'll lock option C, file, as the right answer. Alright, now let's look at this question. We need the type of data store, where we have visual utilization patterns and inter-device relationship. Option A is graph. Graph is suited for analyzing relationship among network devices and their usage metrics. Let's keep it. We'll move to B. B says key value. Key value is not suited for modeling relationships between devices. Incorrect. We'll move to C. C says document. Document is suited for storing nested data, but not for querying interconnections. Let's delete this. We'll move to D. D says columnar. Columnar is optimized for aggregation, not for relationship traversal. Let's delete this. We'll lock option E, graph, as the right answer. So please don't go away. Let's meet in next part of the series.